Right, we're going to start now. Welcome back, everyone. Hopefully you had a really good week, and hopefully you did some of that homework from last week. Now today we're going to look at polynomials. So some of you have probably heard of this term already, and that's all right. This might be like a review to you. For those of you who don't know what polynomials are, that's all right as well, because I'll be doing a good introduction to this term. So before we look at polynomials, we need to know a few prerequisite definitions. So the first definition you need to know is an expression. Expression is basically a combination of variables, constants, exponents, and arithmetic signs, so like addition, subtraction, multiplication, division, used to represent a value. And there's no, unlike an equation, there's no equal sign with this. They're just looking at the value, and you're not like equating like two different values with each other. So for example, you can have 3x plus 5, but there are many, many, many other examples. The second definition you need to know is a term. A term is just a single expression with no addition or subtraction signs. So, for example, you have 4y, and you can also have 1. So I didn't mention multiplication or division in here because look at example 4y. This is 4 times y, so that's basically a multiplication right there. Are there any questions about these definitions? Constant? Oh, coefficient. Sorry, skip that. So it's basically like a constant, but it's right beside a variable. So in here, the coefficient of 3x is 3. Yeah, yeah. So these two are basically kind of synonymous, but still slightly different. Yeah. All right, glad you asked. Let's move on to the definition of a polynomial. So what is a polynomial? It's like an expression, but it's slightly different. It's a combination of variables, coefficients, constants, and the use of addition, subtraction, multiplication, and exponents. So basically, like really similar definition to expressions, but you'll see that it's different. So here are some examples. We have 3x plus 5 from the previous slide. We also have, say, 4x squared minus 1. We could also just have a single constant or number, like negative 10. That's also a polynomial. But there are some rules to define polynomials, like how to differentiate between a polynomial and just like an expression. So first rule, you can't have division of variables. For example, you can't have 1 divided by x because you're dividing like a division. You're dividing by a variable, which is x. So 1 over x and other like similar kinds of expressions are not considered polynomials. Second rule, you can't have fractional or negative exponents. So for example, x to negative 4, because that's basically like divide this x to negative 4. You can also equate that with 1 over x to the exponent 4, which is also like a division of variables. So you can have negative exponents. You also can't have fractional exponents. So like square roots and cube roots and stuff. Those don't count as polynomials. But you can only, so the exponents have to apply to the variables. If they apply to like the constants or like the coefficients, you can still define the expression as a polynomial. But just make sure that it doesn't happen to the variable. And also, last thing, this is not really that important for today's lesson, but you can't have any non-polynomial functions like trigonometry identities like sine, cosine, tangent. We might look at trigonometry like later in this year, but you don't have to worry about this rule for today's lesson. Any questions? No questions? Right. Here are some more definitions that have to deal with polynomials. These are really important, so you guys should jot these down. First things first, a monomial. A monomial. This is a polynomial with only one term. So, for example, we just have the number negative 4. That's a monomial. We can also have binomials. It's like 2 terms, trinomials, 3 terms, and etc. So basically, the number of terms will define like the prefix of the nomial. Yeah, but we won't be looking at these definitions too much. Maybe a bit of monomial, but that's it. And second definition is degree. So degree is the largest exponent in a term with a non-zero coefficient. So here's an example. We have x squared plus x plus 1. So the term with the largest exponent is obviously x squared. So the exponent here is 2. That means that the degree of this polynomial is equal to 2 as well. And here's a side note. If there are multiple variables in a term, so you could have like x, y, or like x, y, z or something, you have to add up their individual exponents to figure out the degree. So for example, you have x times y. X has an exponent of 1, y has an exponent of 1. So you have to add those two exponents up to get a total exponent or a degree of 2. So, okay. Now the third definition is the leading coefficient. The leading coefficient is basically the coefficient of the term with the largest exponent. We take the example of x squared plus x plus 1 again. So remember, the term with the largest exponent is x squared. The coefficient here is just 1, even though like it doesn't show up there, but it's basically 1 because 1 times anything is equal to itself. So that would be the leading coefficient in this polynomial. And last definition, standard form. Standard form is basically a polynomial that is written left to right in order of decreasing exponent. So the the polynomial x squared plus x plus 1 is written in standard form because you're just decreasing the exponent as you go from left to right. So going from 2 to exponent 1 to exponent 0. So constants have a degree of 0. So keep that in mind. Are there any questions? Right, no questions? Let's look at some problems. So for 1 to 6, determine if the expressions are polynomials or not. And if yes, first simplify the polynomial, and then find the number of terms, find the number of terms, the degree, and the leading coefficient of that polynomial. I'll give you guys a few minutes to figure that out. Yeah. And so when I mean by simplify the polynomial, I mean like get rid of any zeros. Anything with 0 does not count as a term. And also you can add variable or subtract any variables that have like the same exponent or same degree. So that's what I mean by simplify. Here, I'm going to change up question 3. It's a little bit ambiguous. Here's have A, B, and C. I'll just make these some random numbers. Like 9 plus 2. There you go. Okay, I changed question 3 to 3x squared minus 9x plus 2. Sorry about the confusion. I'll wait like half a minute. Okay. I think we're gonna take this up now. Does anyone have an answer for question 1? So first, is question 1 a polynomial? Yes, right. Perfect. Okay. And then we don't need to simplify any further. So this is the most simplified term. Okay. How many terms does this polynomial have? Yeah, you guys can just shout it out if you know the answer. So what's the number of terms in? Perfect. So 5x is one term, and -1 is also a term. So that's two terms. What's the degree? Nope, not quite. Not 0. So look at the individual exponents of each of these terms. -1 has exponent 0, but 5x has exponent of 1. Right? X to exponent 1 is just x. Oops, sorry, let me skip forward. So that means 5x would contribute to like the overall degree of the polynomial. So then the degree of the polynomial is 1. Then what's the leading coefficient? Yep, 5. So remember 5x has a high exponent, and we just take the coefficient of that term, which is 5. Okay, what about question 2? Is question 2 a polynomial or not? So you just say yes or no. No. Perfect. Because we're dividing by a variable right here. We're dividing by 3y. So we're treating y as variable as well, along with x. So if we're dividing by a variable, that means the expression cannot be a polynomial. And we can just skip the rest of the question. Now, what about question 3? Is that a polynomial? Yeah, perfect. So we don't see any like division of variables, any negative exponents. We're good. Okay, we don't need to simplify anymore because this is the most simplified form. How many terms are there? 3. Perfect. We have 3x squared. We also have -9x, and we also have 2. That's 3 terms. What's the degree? 2, right? Because 3x squared has the highest exponent out of all these terms, and the exponent here is 2, so the degree is also 2. And what's the leading coefficient? No, not 9. Remember, leading coefficient has to go with the term with the highest exponent, so it has to be 3. Right. Now, question 4. Is this a polynomial? Yeah, it is. Correct. We don't see any division variables, no negative exponents or anything. We're good. Now we have to simplify it because we have 0x4, x to the exponent 4, and we have 0x squared. So basically we can ignore those terms, and they won't contribute to the number of terms in the polynomial. So then how many terms are there for this polynomial? If we're just 2, perfect. We have -5x cubed, and we just have x as well, so that's 2 terms. Remember, we're ignoring the zeros. Those do not count as terms. If once we simplify the polynomial, these guys will be gone. Then what's the degree? Not 4. Remember, we got rid of 0x to 4. Then it's just 3. Perfect. So then -5x cubed would be have the highest exponent. The exponent here is 3. And what's the leading coefficient? Not just 5. Remember, you have a negative here. So it's -5. Yeah, perfect. How about question 5? Is that a polynomial? It is a polynomial, yeah. Here, even though we see like x squared y, we can have multiplication of variables, right? We just can't have division of variables. So this would count as a polynomial. Now we have to simplify it. we notice that we have 2x squared y, and we also have x squared y over here. So that means we can subtract the two. So this would just become x squared y. So then how many terms do we have once we simplify this? Yeah, just 2. Here, I'll also rewrite it so you guys can understand how it's only 2. So remember, we just subtracted these 2 terms because we have x, because they both have x squared y. We're just left with x squared y plus 9. Here. All right. And these are the only 2 terms, right? X squared y, that's 1 term, and 9, that's the second term. What's the degree? Remember that we have to look at the exponents for both x and y, so keep that in mind. What's the degree? Does anyone know the degree of the expression? No, remember, we have to consider the exponent of y as well, and add that to the exponent of x. So remember the note over here. If there are multiple variables in a term, then you have to add up their individual exponents to get the total exponent. So then what is the degree now? 3. Yeah. So x has an exponent 2, y has an exponent of 1. And then you add 2 and 1 to get the total exponent or degree, which is 3. And what's the leading coefficient? Remember, leading coefficient has to be a constant, can't be a variable. It's just 1. Perfect. Right. What about question 6? Is that a polynomial or not? It's not, right? We have square root. So I know this doesn't look like a square root, but it's the closest thing I can find to a square root when I was typing this in Google Slides. But this is square root of x. And we know that square root of x has an exponent, has a fractional exponent. The exponent would be 1/2. And we can't have any fractional exponents or square roots in a polynomial. So that means that question 6 is not a polynomial. That means we can skip the rest of the question. Right? Hopefully these are clear. Let's move on to some other terms. We have expanding and factoring. So what is expanding? Expanding in just a few words is basically breaking apart the brackets. So basically you're multiplying, how it works, you have to multiply each term in front of a bracket to all the terms inside the bracket. And this is called distributive property, if you know that before. So for example, over here, we have 4x times, in brackets, 5y minus 7. If you want to expand the expression, sorry, I keep moving this. Okay. If you want to expand the expression, you have to multiply 4x to 5y, and also multiply 4x to negative 7. So think about like distributing the 4x to both of these terms. So 4x times 5y gives you 20xy. And then 4x times negative 7, also remember, be careful of the sign in front of the 7. So you get negative 28x. So that you're left with 20xy minus 28x. So that's how you expand that. Now, factoring is the opposite of expanding. You're basically putting it's like putting an expression back into brackets. But a better definition would be to express a polynomial using its factors. And to factor a polynomial as much as you can, you have to divide all the terms by the greatest common factor. And this is how you get the polynomial in its factored form. And basically, to find the greatest common factor of terms with common variables, you have to use the smallest exponent of that variable. So say, here's an example. We have 8xy minus 16y squared. The greatest common factor here is 8y. So first things first, we look at the coefficients of these terms. We have 8 and negative 16. We can just treat negative 16 as 16. The greatest common factor between those two coefficients is 8. Now we look at the variables. We see that axy has xy, and then the second term has y squared. We see that both of them don't share an x, but they share a y, and they only share one y, because xy only has an exponent of 1 for the y, and then negative 16y squared has an exponent of 2 for the y squared. Sorry, yeah, exponent of 2 for that term. So we have to take the smaller exponent, which is 1 from the xy. So that means the greatest common factor of these terms is 8y. And when you factor that out, you get 8y times, in brackets, x minus 2y. So that's how you factor that polynomial. Are there any questions? No questions? Hopefully this is clear as mud. Let's look at a few expanding and factoring problems. So you expand these problems, 1, 2, 3, and also factor these problems, also 1, 2, 3. I'll give you guys a few minutes. Wait a few more seconds. Let's take these up on a whiteboard. So this first question, 3x times, sorry, 3z. Sorry, 3z times 4z squared. I think it was my plus 10. Plus 10. All right, can someone expand this for me? Not 7. You're multiplying 3 and 4. Yeah, that's okay. 30z. Perfect. So here we're just multiplying 3z by the terms in the brackets. And we're left with 12z to the cube plus 30z. So that's question 1. So question 2. So 2x minus 1, 2x plus 1. So here we have 2 brackets actually. We can treat one of these as like a singular term. So we like treat 2x minus 1 as like the term in front of the 2x plus 1, the actual brackets. So here we have to multiply 2x from here to these terms, but we also have to do the same with minus 1. I'll draw a few lines just to illustrate that. 2x with 2x and positive 1. We also do the same with negative 1. So like that. -1 times 2x and also +1. And I'll take this up myself actually. So we have 2x times 2x, that will give us 4x squared. Right? Now I have 2x times 1, that's just 2x, plus 2x. We also have -1 times 2x, that gives us minus 2x. And finally, -1 times +1, we get -1. And here we can simplify this. We see that 2x and minus 2x can cancel with each other. And we're just left with 4x squared minus 1. Right. So that's question 2. Now let's look at question 3. I'll open a new whiteboard because it seems to be pretty long. So x minus y. X squared plus 2xy plus 5y squared. All right. So this is similar to question 2, where we have to multiply all the terms inside. We can choose this one, x squared plus 2xy plus 5y squared, with all the terms in x minus y. So I can draw lines again to illustrate that. From here, so we have to multiply x by x squared, 2xy, and 5y squared. Also do the same for -y. Right. And let's expand it over here. So can someone tell me what x times x squared, what is that equal to? Yep, x cubed. How about x times 2xy? So what's x times 2xy? Yep. I usually just put in alphabetical order, so 2x squared y is also good. But you can also write as 2yx squared if like the exponent in between like two variables kind of disturbs you, but this is how I usually write it. How about x times 5y squared? Yep. I just write as alphabetical order, so you can write 5xy squared. Notice that 2x squared y and 5xy squared cannot be added together because we have exponent of 2 for this term, but over here, sorry, for the x on this term, it has an exponent of 2, but on this term, it has an exponent of 1. Also, the exponents for y are different as well. So that means we can't add these two terms together. So just keep that in mind. All right, what's -y times x squared? So now we're moving on to -y. What's -y times x squared? Yeah, perfect. All right, I'll do the rest myself. So -y times 2xy minus 2xy squared. So we're just adding the exponent of y together. And I'll write the final term over here because we're running out of space. Oops, no plus. Minus 5y cubed. That's what it should be. Right. So now we have this really, really long variable. Sorry, this really, really long polynomial, but we can simplify it. So we can combine some of the terms together. We can combine 2x squared y with x squared y over here. 5xy squared with -2xy squared. And that's all we can do. So if we simplify this, we get x cubed. Now 2x squared y minus x squared y just gives us plus x squared y. Then we have 5xy squared minus 2xy squared. That should give you 3xy squared. Right? And then, yeah, so we covered the middle four terms, and then we can just write out minus 5y cubed at the very end. All right, and this is our answer for question 3. Sorry, that took a little bit of time, but hopefully that's clear. Now let's look at the factoring problems. Let's look at question 1. 9x minus 6. Let's have a new drawing. All right, can someone tell me like the greatest common factor between 9x and 6, or negative 6? Or just look at the greatest common factor between 9 and 6. So we're trying to look for a term to factor out for these two terms. 3, perfect. So we can factor out 3 from 9x and 6. And this would look like in the brackets, after we factor it out, we get 3x. So 9x divided by 3 gives you 3x. And we also have negative 6 divided by 3 to give you negative 2. So this is the factored form of this expression. We have 3 times 3x minus 2. That's fairly straightforward. Let's look at question 2. 7x squared plus 70x. Right. Can someone tell me the greatest common factor between these two terms? Like what to factor out? 7, well, yeah, that's part of it. What about, you see both have an x. Perfect. So here we can first look at the coefficients and find the greatest common factor between the coefficients. And here it's just 7. And then look at the variables. And then you just take the smallest exponent of the variable, which is, in this case, just 1. So you have x. So you can factor out 7x from these two terms. So then we're left with x. So 7x squared divided by 7x gives you x. And we can do 70x divided by 7x to give you 10. So 7x times x plus 10. That's our answer for question 2. Question 3 is pretty complex. Let's try to tackle it. So for the x squared, the y squared, z squared, we have 3 variables here. Minus 20x y cubed z. And I believe the last term was like, yeah, 10x y squared z. All right, so we have loads of variables here. But first, let's look at the greatest common factor between 40, 20, and 10. Can someone tell me what that is? So what's the greatest common factor of 40, 20, and 10? So we're looking at the coefficients first. 10, perfect. All right, now let's look at one of the variables. Let's start with x. So we have x squared over here. We have x over here. We also have x over here. We can see that the smallest degree of x is just x. Like smallest exponent would be 1. So that means we can only factor out x. We can't factor out x squared because this doesn't have an x squared. Neither does this. Let's look at y. We have y squared over here. Here we have y cubed. Here we also have a y squared. So you can see the smallest exponent of y is 2. So we can factor out a y squared. Let's look at z. So we have z squared over here. We have a singular z here, and also another singular z for this term. So you can see that the smallest exponent would be 1. So that means we can only factor out a z, not a z squared. So when we factor that, we get, so we're dividing each of these terms by 10xy squared z. So when we do that for the first term, we get 4xz. Now for a second term, we can divide 20 first by 10 to give us negative 2. divide x by x, they cancel out. Y cubed divided by y squared gives you y. Z's also cancel out. And then the final term. We see that they're the same thing. 10x y squared z. Here's also 10x y squared z. They all cancel out, so we're left with 1. So that's our answer for question 3. Are there any questions about these problems? No questions? Right. Let's look at a special type of polynomial. And these are called quadratics. Quadratics are basically polynomials with a degree of 2. And many have the form of like ax squared plus bx plus c, where a, b, and c are your constants. So don't treat them as variables, you treat them as constants. And when you graph these kinds of polynomials on our Cartesian plane, the graph is called a parabola, and they usually have this like bowl shape right here. So something like that. We might look at graphs later this year, but we don't have to focus on that for today. Just know that quadratics have a degree of 2. Okay. Now let's look at how to factor quadratics. So the factored form for a quadratic expression usually consists of 2 linear polynomial factors. So for example, we have ax plus b in brackets times, in brackets, cx plus d. Let's look at how to factor a quadratic expression of form x squared plus bx plus c. Notice that a here is just 1. And it's a bit more complex when you add when you have an a that's larger or less than 1. But I'll go over that in the next slide. First, let's pretend that the coefficient of x squared is 1. So step 1 here is find 2 integers that multiply together to get c and add together to get b. And let these 2 integers be called m and n. So remember that m and n have to multiply to get c, so m times n equals c. And then m plus n has to equal b. Right? So let's call these integers m and n. So that means the 2 factors, so when you factor out your quadratic, the 2 factors will be x plus m and also x plus n. And then now let's look at an example of x squared minus 3x plus 2. So let's try to find 2 integers that multiply together to get c, which is positive 2. And when you add together, they get negative 3, which is b. And 2 integers in this case is negative 1 and negative 2. Someone just joined. Bob just joined. Right. So I Bob the attendance. I think I'll put zeros for these guys. Alright. So yeah, Bob, we were just looking at how to factor quadratics. And if you missed the beginning of the slideshow, I'll post a recording of it. I'll post a slideshow and then the recording of it later today. But yeah, we're just talking about polynomials. That's the topic for today. But right now, we're looking at how to factor this quadratic, x squared minus 3x plus 2. We're trying to find 2 integers that multiply to get positive 2 and that add to negative 3. And these integers are negative 1 and negative 2. Sometimes you can just use guess and check to figure these out, but you can also look at all the factors of positive 2, like positive and negative factors of plus 2, and figure out which ones will add to negative 3. So that's a simpler way to guess and check these integers. And then when you factor this out, you get x minus 1 times x minus 2. So that's your factored form of this polynomial. Are there any questions? No questions? Right. Now let's look at how to factor a quadratic with ax squared plus bx plus c. And here I want to mention that a is not equal to 1. So in our previous case, we had a equal to 1, so we just have an x squared on its own. In this case, we're treating a as if it's not equal to 1. And the steps are slightly more complex, but should be fairly straightforward as well. So first thing first is to find the factors of a and c and pair them up. And when I mean factors, I also want to add negative factors as well. And basically you pair them up, like the ones that multiply each other to get A, and the ones that multiply to each other to get C. So that's what I mean by pairing them up. Now the second step is to choose a pair that multiplies to A. So let's call this A1 comma A2. Another pair that multiplies to C. Let's call it C1 comma C2. Such that A1 times C2 plus A2 times C1 gives you B. That means your factored form would look like A1x plus C1 times A2x plus C2. And let's look at an example of this just to make it more clear. So we have 2x squared minus 5x plus 2. First, let's look at the factors of A, which is 2 in this case. We have 1, 2, and we also have to consider the negative factors as well, which is -1 and -2. Right? Now, factors of C is also equal to 2, are the same thing. So 1, 2, -1, -2. Now we have to choose a pair from this line over here, from A, also another pair from C, so that A1C2 plus A2C1 is equal to B. And you can basically do guess and check for this. It might take a while, but you'll get to it eventually. Here I chose 1 comma 2 from A. From C, I chose -2 comma -1. So we want to test it out with here. We have A1 times C2, so 1 times -1 gives you -1. For A2C1, we have 2 times -2, which gives you -4. -1 plus -4 gives you -5, and -5 is equal to B over here. So that means your factored form would be x minus 2, so A1 is equal to 1, so it gives you x, plus C1. C1 is 2. Wait, sorry, C1 is -2, my bad. C1 is -2 right here, so that gives you -2. Right. For a second factor, you have A2. A2 is 2 right here. And you have -1 for C2. C2 right here is -1. So then you have x minus 2 times 2x minus 1. That's your factored form for this equation. Are there any questions about this? No questions? All right, let's move on. We can move back. We can go back to this if we need to, because the concept's a little bit confusing. Okay, let's look at some special kinds of quadratic expressions. Sorry. So the first one is a difference of squares. So a difference of squares is a quadratic expression with the form x squared minus y squared. And then the factored form for this quadratic in particular is x plus y times x minus y. So basically you're taking the square root of these terms and you're putting them as their factors as well. But for the first one, you have x plus y. The second one, you have x minus y. And if you want to test it out, we can. So let's look at this. Say we expand x plus y and x times x minus y. We get x squared minus xy plus xy minus y squared. Sorry, that was a bit too quick. So multiply x by x to get x squared, x times -y to get minus xy. Now we do it for plus y. Plus y times x gives you xy as well. Oh, plus xy, not negative xy. And then plus y times -y gives you negative y squared. So you see that negative xy and positive xy cancel out. And you're left with x squared minus y squared. And we have it, and let's take an example of a difference of squares. So we have 4x squared minus 25. If you just factor it out like this, you get 2x plus 5. So the square root of 4x squared is 2x. Square root of 25 is 5. So for the first factor, we add the two terms, 2x plus 5. And for the second term, you can subtract the 2. So well, for the first factor, you can either add or subtract. But then for the second term, you have to do the opposite. So we decided to do plus and minus for here. So 2x plus 5 and then 2x minus 5 would be your factored form. Are there any questions? No questions? Let's look at another special quadratic. We're going to look at perfect squares. So this would be a quadratic expression with the form of a squared x squared. So treat a as like a constant. I'm sorry, a coefficient. A squared as a coefficient. Plus 2ab xy plus b squared y squared. B is also a constant or coefficient. And the factored form for this equation would be ax plus by, all that squared. So this is what I mean by a perfect square. So in fact, so this expression right here is a perfect square. So this is what the factored form looks like. Basically, for the first term in the bracket, you take the square root of the first term for the polynomial. So a squared x squared, square root that to get ax. For the last term, you have b squared y squared square rooted to get by, all that squared. And you have to make sure that the middle term looks like this, 2abxy. So 2 times a times b times x times y. And if we expand that, so we want to double check like this works. We have ax plus by squared. First thing, we can write the two terms, so like the exact same term of ax plus by side by side. And that way we can look at like the multiplication. So when we expand this this expression. So we get ax times ax to get a squared x squared, ax times by to get a times b times x times y, abxy. Then we can look at by times ax to get abxy. And then we have by times by to get b squared y squared. We notice that we can add these two terms, so abxy, we can add them to get 2abxy. And then we're left with a squared x squared plus 2abxy plus b squared y squared. So we can see that this works. And then just to show an example of factoring in perfect square, we have x squared minus 4x plus 4. The factored form of this would be x minus 2 squared. So we took the square root of x squared to get x, square root of plus 4 to get 2. But we need to consider the sign as well. So if the sign of the middle term, so negative 4x, if the sign is negative, then you have to subtract 2. If the sign was positive, say this was plus 4, then this will have to be plus 2. So take the sign into consideration. And we also have, so term 2abxy has to equal negative 4x. So let's test it out. So ax, so it's just x, and then we have by. by is negative 2. So abxy would be x times negative 2 to give you negative 2x. But you also have to multiply by 2. So negative 2x times 2 is equal to negative 4. So that means this is a perfect square that you can factor like this. Are there any questions? I think that part was a little bit confusing when I mentioned like the negative 4x equal to 2abxy. Let me write it out. Like this. So 2abxy. Okay, so ax is equal to x in this case. by is equal to negative 2 in this case. Now we want 2abxy. So we can also write as 2ax by. I think I'll make it more clear. 2ax times by. 2 times x times negative 2. And that should equal negative 4x. So basically, another way to look at it would be like, if you want to look for an ax, so if you want to look for the first term, and if you want to look for the second term, you want to make sure like the first term is the square root of the first term of the polynomial. The second term in the brackets is the square root of the last term of the polynomial. And you want to make sure that when you multiply these terms together, so x times -2, and then multiply that by another 2, because we have 2 here, 2ax by. So x times -2 times another -2. Sorry, x times -2 times another 2 would give you this middle term, -4x. So hopefully that makes it more clear. Now let's look at a few problems. I think that's what's coming up. All right, so here are a few problems. Factor the following quadratic expressions. I think we're running a bit out of time, so I'll just do question 1 to 3. You guys can just do question 1 to 3. Actually, let's do this. Okay. Actually, you know, just do this for simplicity's sake. Just do these 3 problems, because we're running a bit out of time. Try these out on your own. A few slides left. Right. I think I'm going to take them up now. Let's take these up. So question 1. X squared minus 8x plus 16. We can go about this in a few ways. We can factor this using the method where like you have x squared plus bx plus c. So we have a is equal to 1. Yeah, your question. I'll try to make it as quick as possible. Probably like maybe an extra like 5 or 10 minutes. Hopefully, is that fine? Okay. Yeah, sorry if I'm going a bit over time, but we started a bit late as well, so hopefully that compensate for that. So if we're trying to factor x squared minus ax plus 16, we notice that it could be a form of x squared plus bx plus c. We could try it out. Or if you notice that, it's also a perfect square. It's a form of perfect square, where you have a squared x squared. So in this case, square root of x squared gives you 1. Sorry, a square root of x squared just gives you x. We notice that 16 is also a perfect square. So first term and the last term have to be perfect squares in order for this strategy to work. So 16 is a perfect square. If we square root that, we get 4. And then we have to multiply these 2 terms together and multiply by 2 as well. So 2 times x times 4. This only gives us ax. If we want a negative, so if we want negative ax, we have to add a negative to 4. We can't add to. You can add to x, but usually we don't put negatives in front of the variable. So we just add it to the 4. So that means we have x minus 4 squared in brackets. So that. So that's how you factor this perfect square right here. X squared minus x plus 16 is equal to x minus 4 squared. Let's go back to the problems. Okay, question 2. X squared minus 1. So here you notice that it's a difference of squares. You have the form of x squared minus y squared, or x squared and y squared are both perfect squares. X squared is perfect square, and 1 is also a perfect square. So it means we can write this as x plus 1. So we square root both these terms, and we add them and then subtract them as well. So first we can write x plus 1, and then for a second factor, we can have x minus 1. So that's how you factor this polynomial. Now let's look at question 3. Question 3 does not, so this does not look like a perfect square because 18 right here is not a perfect square. Sorry, yeah, it's not a perfect square, so that means we can't use this perfect squares strategy. That takes a while. And also it's not a difference of squares because as well, 18 is not a perfect square. So we can't use any of those strategies. So then we have to go through this. We have to find two integers that multiply to c and add to b. And also a is equal to 1. So it means we can't use that strategy. So let's try it out. So x squared plus 7x. So I want to look for two numbers. Here, let's call these a and b. Two numbers that multiply to negative 18. And they have to be integers. That means a and b have to be factors of 18. And a plus b gives you positive 7. Right? Can someone give me like two possible numbers that satisfy this? Negative 2 and 9. I don't think the order matters, so we could say a is negative 2 and b is positive 9. Whoops, my bad. That was really bad. Okay, so we have two numbers, negative 2 and positive 9. And if you want to write those out as factors, we have x minus 2. And then we have also x plus 9. And that's how you factor this polynomial right here. Are there any questions? No questions? Right. We just have like 3 more slides. Some people might have to leave early, but I should be able to. I'll post like the recording and then the slideshow as well later today. But let's look at how to solve a quadratic equation. So this time we have an equal sign. So if you want to find steps to solve a quadratic equation, first, if needed, you have to move all of the terms to one side of the equation. So like all the variables and constants to one side. This is different from like in the past where we have constants and variables like separated, but when we're trying to solve a quadratic equation, we have to move all of them to one side. And that way, if you look at question step 2, we have to factor the quadratic equation. So the expression, you have to factor that expression. And then step 3, final step, for each factor, like within the quadratic expression, for each factor, you have to set the factor equal to 0 and then solve for the variable. And this is called a zero product rule. So basically for a zero product rule, if a term in a product is equal to 0, then that entire product is equal to 0. So that's what the rule states. Now let's look at an example. So we have x squared equals 9x plus 10. First thing, we have to move all of these terms to one side. So we can move 9x plus 10 to the left side to get x squared minus 9x minus 10 equals 0. And then when you factor that, so if you want to like factor it, first find two numbers that multiply to negative 10, and those numbers also have to add to negative 9. And then we're left with negative 10 and positive 1. So you can guess and check those numbers. But it works. So we have x minus 10 times x plus 1 is equal to 0. Now if we do step 3, we have to set each of these factors equals 0. So x minus 10 equals 0, or x plus 1 equals 0. And when one of those equals 0, then the entire thing is equal to 0. And you don't have to care about like what the other term is equal to. So if you solve these small equations, you get x is equal to